Welcome to our webcast, Cybersecurity Technologies and Strategies, Tips for Industrial Control Systems. I'm your moderator, Peter Wielander, and I'm happy to join you today on behalf of Control Engineering and Oil and Gas Engineering. All right, I'm now happy to introduce today's distinguished speakers. Toby Cahoon is a research analyst in the Discrete Automation and Switchgear Group at IHS. His research interests range from control systems, HMIs, cybersecurity, industrial communications, switchgear, and embedded systems. Toby is a speaker at industry events worldwide and has also worked on multiple custom research reports. Toby holds a BSc in chemistry from the University of Leeds. He is based in IHS's office in Houndsditch and can be reached at toby.cahoon@ihs.com. Chris Shipp is a columnist, speaker, and consultant with more than 2 decades of experience in the field of information security. He has provided cybersecurity training and support for many commercial and government entities, including the FBI and the U.S. military. Currently, he is working within the cybersecurity community to develop, implement better information security within industrial control system environments. Matthew Llewellyn is co-founder of Sabati, an educational institution focusing on critical infrastructure and control system cybersecurity. Mr. Llewellyn educates extensively on process control, SCADA, and cybersecurity issues with Sabati, and also as adjunct faculty at DePaul University. Prior to incorporating Sabati, Mr. Llewellyn was a co-founder of Encari, a NERC-CIP cybersecurity consulting firm. Mr. Llewellyn also served as an information security network engineer and architect at Argonne National Laboratory within the United States Department of Energy. Mr. Llewellyn is a 16-year CCIE, a 13-year certified instructor for the SANS Institute, and a 16-year CISSP. Matt has a BS in Industrial Engineering from the University of Illinois, Urbana, and an Master's in Computer Science, National Technological University. I'm Peter Wielander, webcast moderator for Control Engineering. Before we continue, please take a moment to remind yourself about dealing with technical issues during the presentation. Now, to start our webcast, we'll hear from Toby Cahoon. I'm afraid Toby is in England at the moment, so he won't be available for the Q&A segment. All right, Toby?
So hi everybody, my name is Toby Cahoon and I'm an analyst with the Industrial Group at IHS. And today I'm just going to talk about some of the diverse drivers behind cybersecurity and some of the things that you need to be aware of. In this first slide, this just sets up the scene around our first problem. Many organizations are reporting way more data breaches than in the past. I've taken this slide just from the Verizon Data Breach Investigations report, which is a great report which I'd encourage everybody listening to go offline and have a read because there's some really interesting information in there. But one of the take-home messages, and it might be a bit counterintuitive, is that cybersecurity is affecting all industries. So whereas 10 years ago it might have been considered more of an enterprise or an IT issue, it's affecting industries that might not be perceived as vulnerable, but they are, and manufacturing especially is one of the top targets for people trying to steal data. And in fact, the problem's even bigger than just data theft. A lot of automation systems, and we'll talk about this a bit later, are relatively elderly. And security has probably been a bit of an afterthought. So many of these systems are in some way kind of magical or a bit fragile, and they probably aren't as robust in terms of cybersecurity as they could be. So 2 examples of that is that in many cases automation systems might have relatively flat networking topology, or many people might have way more privileged access to data or operations that they probably don't really need access to. So not only do we face the problem of malicious threats, which is captured in the Verizon study, but even internal threats or unintentional threats, increasingly we're just as vulnerable to those as well on the manufacturing and processing side. The next slide is more industrial specific, and once again, some more facets of the problem, and as I'm sure everyone online is aware, this is a multifaceted problem. Now, one of the things we track is that we look at the number of devices that make up modern control systems. That's control systems in the sense of a methodology in terms of network of devices that produce some output rather than just PLCs or DCSs on their own. Obviously, they'd be part of it, but it's about control systems in a more holistic sense. Now, all these devices, no matter what industry you look in or what application you look in, they're becoming increasingly connected. The benefits of connectivity are tangible, they're here to stay, and they're affecting all devices. And that's just going to keep growing and growing. On the flip side of that, we're leaving ourselves vulnerable in ways that weren't necessarily intended by the designers. So I mentioned before that in many of these devices, security is an afterthought. And in industrial, we're working in very capital-intensive industries. Industries that have a very long replacement life cycle. But what that means is that devices that have these inherent vulnerabilities, they're going to take a long time to be weaned out of our control systems that are very important to us. One aspect of that is just purely connectivity. So that pie on the right-hand side, that's kind of who's who in the zoo of protocols. So it takes that same data on the left-hand side, which devices were connected, but splits it by protocol instead of device. Now, what we see is that a wide variety of protocols are in use, but once again, what might be a bit counterintuitive is that a lot of these protocols are still connecting these devices using legacy field bus technologies, and many of these technologies have well-documented vulnerabilities and are in need of modernization. In this next slide, although manufacturing has a relatively stable, or is perceived to be relatively stable and staid and not much changes and static, manufacturers are actually quite forward-looking in the technologies that they adopt. So this data is taken from a survey of engineers, and we asked those engineers which ones are affecting your enterprise, and are you using it now? Will you be using it? Is it not of interest at all? And so you can begin to see which technology trends, many of which are defined by the enterprise or consumer worlds, are beginning to become more popular in future. What we see is that although, once again, manufacturing and processing has a reputation to be relatively slow-moving, that's not actually true. What we see is that industry is adopting a wide variety of the latest, most modern business practices like BYOD, like virtualization, like wireless technology. We will hear about wireless HART and ISA 100s, but even things like standard Wi-Fi, virtualization. Once again, there are tremendous benefits. So you don't necessarily have to deal with as many obsolescence issues anymore. You potentially have lower hardware costs in future because you're not tied to a single platform, and these things are here to stay. So not only do we face a big issue with legacy systems, increasingly new technology also creates issues around security as there are potential new threats and vulnerabilities. So in the next slide, we begin to look at some of the responses to this. And once again, this data is taken straight from a survey of engineers. I guess this is kind of like one of those is the glass half full or half empty questions. So you could take two tracks with it. You could say, well, it's great that even in an immature space and an ill-defined space that companies are spending more money on stuff. On the other hand, you can say, well, it's actually shocking that 50% of people aren't buying anything. And by the way, we think that bringing external people in is an essential ingredient for any successful cybersecurity program, because anybody that is internal, although they might be technical skills and very capable, if they're stuck in their silo and they might be facing kind of the same problems day in, day out, we don't think they'll be able to bring as much value as people that work in this day in and day out, and it's their core competency, and they've seen a variety of problems in a different industry. So buying from an external supplier, although there will always be some things people choose to do in-house, we think buying from an external supplier is a key ingredient for any successful program. The next slide breaks down of those people in the last slide that do buy products, what do they see as the perceived reasons why they're buying it. Obviously, these factors aren't necessarily mutually exclusive. So if you spend, $1 on cybersecurity or $100,000, you can, to a greater or lesser extent, there's no reason why you can't achieve multiple benefits. But it's always interesting to ask people, well, what's the primary reason? I think this is really encouraging. What you can do is you can kind of divide these factors into kind of those carrot factors. So the positive reasons people are investing in security, like protecting intellectual property, companies realize that what they have is really valuable, so they need to invest to protect it, versus those stick type factors like fear of fines. So it's well known, for example, that a high impact issue from NERC-CIP per site is worth a fine of $1 million per violation per day. But as I say, it's kind of encouraging that people perceive as the good reasons to invest in cybersecurity, such as safety and protecting intellectual property, things that have value. These are perceived as the drivers towards higher spending, rather than those stick-type factors. The last slide is just a quote from one of the participants in our survey of engineers. Management is in the dark usually, and IT can do whatever they want. So it's kind of a tongue-in-cheek type quote. What you don't want to do is describe your current cybersecurity program. Ultimately, what we see as a key ingredient of success is that the IT guys and the operations guys have to work together, because it is everybody's problem. If you are in the management, then it's on you to get educated on the facts that are out there, because they are out there, and there's no use just sticking your head into the sand. Ultimately, a lot of these problems, they are solvable and they are tackleable. So it is something that everybody at enterprises of all sizes and in all industries should be considering. So that was just a very brief overview of some of the drivers behind cybersecurity, and with that, I'd like to hand over to the next speaker.
All right, thank you, Tony. Toby. Now we'll hear from Chris Shipp.
Thank you, Peter, and thank you, Toby. I appreciate the good words there. I'd like to take a few moments and look at some practical steps that you can take to enhance your cybersecurity program with respect to your control system. If you already have a good mature program, and if you don't have a mature program yet, some things that you may be able to do to develop one. So we'll start with the 3 laws of cybersecurity success. And those are, first, to start with the right team. So no venture that you take in business, as most of us well know, will be successful if you don't have senior management support. So somehow you must make your senior management recognize that cybersecurity now, with respect to your control system, is critical to the success of their business. If your control system is compromised, it could result in fines, could result in loss of revenue, many other negative aspects, and so it's important that your cybersecurity or that your control system be properly protected to maintain business viability. Secondly, you need a knowledgeable cyber business advocate, and really this is the person that performs that first role that I was just speaking of. And this person should be someone who understands both business and understands the technical side of cybersecurity and operational technology. So that's sometimes a difficult person to find. So, for example, this person should be able to speak at least at a high level about technical issues and technical cybersecurity protection mechanisms with technical support personnel, and they should also then be able to take that information and go into the boardroom and translate that into business risk and financial information, so that the risk and how to fix it can be relayed to senior management in a way that they can understand. Then finally, the third element that should be on your team is skilled technical personnel. And I agree completely with Toby. One way you get skilled technical personnel with respect to cybersecurity is to occasionally, or as often as you can afford it, have external validation. Have someone who works every day, every week of the year on cybersecurity come in and evaluate your system, perhaps do a penetration test, but more than that, also just look at how your system is constructed and help you to mature it and to find any vulnerabilities that may exist and to mitigate those. So that's one way you can do it, by bringing in external personnel. But also what you should do, to the extent that's feasible, is to train your internal personnel, because this is a task that really cannot be accomplished solely by external validation. You need someone that's working with your control system environment on a day-to-day basis that has some level of advanced skill in cybersecurity. And the second element to a good cybersecurity program is to use a proven methodology. Now, there are a lot of methodologies out there about how to build and maintain a cybersecurity program, and they really all follow a very similar format. But a good one to reference is the NIST Framework. For those of you who aren't familiar with NIST, NIST is the National Institute of Standards and Technologies. It's part of the U.S. government, and they produce standards that are free for use for the public. One of the standards that they've produced is the NIST Framework for Improving Critical Infrastructure. And that NIST framework has 5 major steps. One is to identify, and that is to identify the devices in your control system. And the premise there, and you'll see this in standard cybersecurity or traditional cybersecurity, as well as in control system cybersecurity, and that is we cannot possibly know how to secure our environment if we don't know what's in our environment. So you need to develop a system, a methodology to identify and understand what's in your control system environment. For example, when a new design is produced to implement something new in your control system environment, are the personnel or is the department that's responsible for cybersecurity notified so that they're aware that new equipment is being installed? So that's important. And then secondly, learn how to protect that equipment, to detect any potential attacks against it, to respond and recover. So that's a mouthful, and really that defines an entire program, and we could speak for a good time about that. But I think that you can reference on the NIST.gov website, and they have more information about how you can implement a program using those steps. And then the third component of a robust cybersecurity program is to use a balanced approach. One of the things that has been prevalent recently in cybersecurity discussions at most of the major conferences is the fact that you will get hacked. No matter what, you will get hacked. Now, that's usually talked about with respect to a business network, but it's also true eventually of your control system. In fact, a recent hack called Energetic Bear hacked over, if I recall, 2,500 control systems via business systems. And most of the people who were hacked didn't know it and had to be informed by outside parties. And so the point there is that the balanced approach is not only prepare yourself and defend against attacks, but also understand that you will get hacked. So have mechanisms in your cybersecurity program that can detect indicators that you've been hacked, and work just as hard on how you'll respond to a successful attack as you do on how you defend against attacks in the first place. And part of that process is vulnerability management. So what do we mean by vulnerability management? Well, first, you need a written enforceable policy. The key to that policy is you need a policy that defines how quickly those who are responsible for control systems must patch security vulnerabilities. But as many of you know, that's much more difficult in a control system environment than it is in a traditional business environment. And that is because sometimes manufacturers haven't yet approved patches. For example, probably many of you, if you're involved in that process, are familiar. Microsoft will release patches, usually on the second Tuesday of the month, but your control system vendor may not yet have vetted those patches and approved them. So when you develop a vulnerability management procedure with time frames for implementing and installing patches and fixes, you have to have it flexible enough that it accounts for these things. So it must really be a marriage of flexibility and accountability, and that can be difficult to do. That's one of the things that we, and I'm sure Toby and Matt, help our customers with, is to develop programs that are both flexible enough that they meet the unique requirements of control systems, but still maintain accountability. And then you must require frequent reporting to senior management. So someone in the senior management chain needs to understand which vulnerabilities are in your environment, especially if they have to remain there for an extended period of time. And as I said earlier, you will get hacked repeatedly. It's a fact of life. It will happen. It may not have happened to your control system yet. I hope not. But chances are in the future, it will. And so you want to have a good incident response process. And some of the things that you can do to do that is develop a detailed playbook. And that's one of the reasons that's important is because I've been involved in many incident responses, and fatigue and confusion are factors that are prevalent. So developing a detailed playbook to help people to understand what their roles are and what they need to do, and then practicing going through an incident helps your staff to work well and to be effective when an actual incident occurs. I'm reminded of the famous quote by basketball coach Bobby Knight, "The key is not the will to win. Everybody has that. It's the will to prepare to win that's important." And so incident response is good preparation. And then I'm going to give you three, maybe a little more specific steps that you might not have heard of, and hopefully they're very helpful to you. And step one is to know your borders and secure them. So for example, a hacker may try to hack your business network. Now you'll notice in this picture that I have the business network, and you might say, what does that have to do with the control system? Keep in mind that in many, many cases where we see successful hacks against control system, first the hacker hacks into the business network and uses it to pivot to the control system. So in this case, the hacker may try to go through your firewall or whatever defenses you have on your network and is unable to do so. So instead, they learn of a vendor that you use, and that vendor may have a connection to your business network or even directly to your control network. Now, in my experience, I've found that many times, even if you have excellent cybersecurity, often those vendors that connect into your network, perhaps through a VPN, do not. And so it's much easier to compromise your vendor than it is to compromise you. And so via the vendor's network, the hacker is able to hack your network. And that's actually what happened. Many of you are probably familiar with the recent Target breach, which was not necessarily a hack on a control system. Well, actually, in a sense it was, because it was a hack through their HVAC vendor to their HVAC system and then was able to jump onto their corporate network. So this same sort of thing can happen to your control system, either via your business network to your control system or directly to your control system if a vendor has direct access. And speaking of that, you should be aware of the pivot. And what does that mean? What that means is once a hacker's on your business network, typically I would imagine that everyone on this call has the need for information from the control system to somehow make its way to individuals on your business network. So how does that happen? Well, one good way to do that is actually in this drawing, and that is if you separate your business network from your control system network with a firewall, and then you put what's called the DMZ, for those of you who are familiar with that, it's really a third leg on your firewall, so that the correct way to do it would be that data coming from your control system, for example, your data historian, would go to the DMZ servers, and then your business network perhaps could connect to the DMZ network where the data has been loaded, but the business network could not connect directly to the control system. Now that's the correct way to do it, but if that's not configured properly, then a hacker may be able to, and I've seen this happen, once they've gained a foothold on your business network, do in hacker terms what's called pivoting. They would pivot from that machine that they have control of on the business network, discover the servers on your DMZ, gain access to them, and then be able to pivot into the control system. So in this scenario, I want to make it clear, if it's configured properly, then it works very well. But misconfigurations can allow what's illustrated to happen. Also, it's very important, and this is one thing I almost never see, to develop a good risk analysis methodology. So how do you do that? I'm going to give you some very specific practical advice on the next slide that I think will be helpful to you. But you start by defining key risk stakeholders. Who is it that must accept this risk? Then create a risk management procedure that involves them, their approval specifically. Perform a risk analysis for every significant change to your IT environment. Now, I almost never see this happen, but what do I mean by this? Well, let me give you an example. Let's say someone adds something new to your control system, whatever it may be. These are the three questions that you should always ask. And one of the questions I get asked is, how do you build a risk analysis? And the answer is you use these three steps. Determine how the system authenticates, what are the communication paths, and then data protection in transit and at rest. So, and then focus on your critical assets. So, if you have a specific asset on your control system that's critical, then you should send alert information when someone tries to access that system in a way that they shouldn't. And that alert information should be provided to the appropriate party so that they don't have to dig through a log to find this, but they can find it readily, and it actually alerts them via an email or some other method that's called to their attention. And then, as I mentioned before, incorporate external validation. You can do this through regularly scheduled penetration testing. And then lagniappe, that's a Louisiana word where I'm from, and it just means extra. And that is, you should try to integrate Sandbox and host file integrity solutions. What does that mean? It simply means that when traffic traverses your network, a dynamic sandbox is a system that takes a copy of any file that would pass by and runs it to see what it does, to determine if it's malicious code. And this is usually much more effective than antivirus software or other technologies, because it's actually running the code to see what it does, to see if it's damaging. And then use an internet proxy for your business network. This isn't your control system, but keep in mind that often when hackers successfully hack your control system, that's via your business network. And therefore, if you can stop them before they can hack your business network, then they're less likely to be able to get to your control system. And an internet proxy is a device that would help you to do that. So, parting thoughts. When thinking about hacking, you have to think outside of the box. You have to think like the bad guy so you can protect your network. I'm a big fan of Mitch Hedberg, and one of his routines says an escalator can never break, it can only become stairs. You should never see an escalator temporarily out of order sign, just escalator temporarily stairs. Sorry for the convenience. So that's a little tongue-in-cheek, but the important thing there is be aware and willing to think outside of the box so you can understand how hackers might be able to get into your control system. In conclusion, what does the future hold? Well, the Poneman Institute says that 68% of IT security executives say that their system has been compromised at least once in the last year, but only 28% consider cybersecurity a top 5 priority. So we still have a disconnect there. Based on that, I think the future holds more successful hacks, unfortunately, in the oil and gas sector, and that near future hacks will be more devastating and cause more physical damage. Thank you for your time, and with that, I'll turn it over to Matthew.
Don't go away yet, Chris. You made a comment early in your presentation about the fact that you feel it's important to have one of your people that works with the plant networks to be trained for cybersecurity. Is that something that's generally fairly successful? That's an easy thing to do, or is that a difficult thing and it's hard to get somebody to train that way?
You know, I've found in the last few years that it's become easier, and I think one of the things that it does, now keep in mind, sending someone whose primary role is operational technology to a cybersecurity training event is not going to make them an expert. But it does make them more aware of the issues, and it also makes the relationship between the OT folks who work on control systems and the cybersecurity personnel who may be more traditionally business-minded. It tends to smooth over that relationship, because then they can, number one, they can speak to the operational person in a language that he or she may understand better now. And number two, it makes the person on the OT side more aware of the potential security issues and more amenable to spending some time and effort to mitigating them. Now, I'll give you an example. There's one site recently where I worked with them a couple of years ago, and there was a lot of hostility between the operational side and the IT side with respect to cybersecurity and where it should be implemented. And I recommended that they train a few of their folks on the OT side. Went back recently and to a meeting where I was sitting there, and the person on the OT side was pushing hard to implement more cybersecurity, harder than the cybersecurity folks. So I found that an interesting change.
All right. Well, okay. Thanks, Chris. And now we'll move on to Matt. We have a lot of material yet to cover, so we may extend this a few minutes past the half hour. So stick with us. We may turn this into a 65 or 70-minute webcast. So go ahead, Matt.
Great. Thanks, Peter. And thank you, everybody, for joining us today on this very, really important topic as has been discussed so far. So, one of the questions that came in as we were going through this presentation was just, some of the emphasis of topics and security frameworks and understanding the differences of proper application of the controls versus just focusing on the framework. And the reality is you have to have a combined approach of that. You want a commitment by management of a centralized framework that you're going to be in, but then at the same time you need to make certain you have the proper application of security controls for an ICS environment, right? And that's where things are a little different from IT. Now, are there elements that are similar to this big transition we've had for the past 5 or 6 years or so of this Internet of Things world? Well, yeah, absolutely there is, and it's all about because we're controlling and sensing from the physical world. And so, that is the big difference that we have from traditional IT applications. That and rolling a real-time operating system that we're managing, there's a lot of elements that we're trying to handle correctly. We're going to be discussing some ways to manage the risk. Then we're going to get into a lot of detail on some applications that you can use to better protect your systems. And we'll have some specifics. So we'll go high level as well as low level as part of this presentation. The other thing I was afforded the opportunity of during this presentation was to be able to do a little survey. And you're going to be seeing a survey pushed out to you now around ICScert notices. So as that survey is going out there, the question is, wondering, are you even aware of the ICScert? Do you have a mechanism in place to know about not just vulnerabilities in your own environment, but vulnerabilities that are happening within the ICS realm? And you can rely just upon your vendor to share that information with you, but we truly recommend that you also have an additional approach that you're learning about vulnerabilities that are happening, not just from CNN or from the media centrals, hopefully again in this case from CFE Media, right, as we're looking at it here, but also other utilities that are available to you like the ICScert, which has now been around for several years. In fact, I think they began back in 2005 or 2006. You can correct me, anything. I know people that may be on the line. But point being that ICScert as a part of UScert can let us know about vulnerabilities that are happening for specific types of software and hardware, as well as campaigns that are occurring in the environment, and further, even some good guidance, right? So it was December of last year where some guidance came out on how to go and protect your GPS antennas, right? So if you're using that not just for latitude and longitude, but also for your clocking and signaling in your environment, how do you actually go and architect that correctly to go and manage it? So there's a lot of great information out there. And I don't want to spend a lot of time discussing Stuxnet or Black Energy or Energetic Bear or Havix or Dark Hotel, but I do want to give you the search phrases to look for, right? Those phrases that pay, so you can then know that some of these vulnerabilities are out there and some of these campaigns have been occurring. Stuxnet, majority of people already know about that, but maybe you didn't hear about Havix when that was revealed, about 15, 16 months ago, that there was an attack against OLE for process control, as well as compromised ICS vendors which then all of a sudden you would receive Trojan malware as you downloaded updates from a vendor. Furthermore, you get into dark hotel that was specifically targeting executives using open wireless networks at hotels to then be able to have that pivot point in the corporate environment, then subsequently possibly getting into the control network from there. Of course, you also have the inverse, right? What about compromising the control network to get into the actual corporate network at the same time? So there's a lot of directions you can happen as far as how things can be compromised, as well as understanding the risk. But ultimately, what we're trying to do is how can you find a good way to understand and transfer knowledge of risk to your colleagues? And that's where it gets into understanding some of these security frameworks and how we're going to manage it. So, looking at the survey here, in between yes and no, and who actually is, let's see, I'm trying to look here. I have to scroll down. Give me just one moment. So 30% are actually aware of the ICScert and looking at some of those notices that are coming out, and we have about 70% that are not aware of that. So, highly recommended that you take a look at those tools that are available to you to be able to know what's ongoing in the environment. And it's better to know about it externally than when it hits you internally. So keeping aware of that information beforehand when the government and other entities are providing that to you is really invaluable. So be aware of the ICScert and even the UScert portal that may be available to you as a critical infrastructure participant to be able to gain access to information earlier on that's happening. Now, some other touch points and getting a bit more technical and not just that framework around this, and thinking about how to share the risk and some questions to be asking, and some problems and challenges that we've seen, with my hat on as a consultant, right? It was brought up in the introduction that I own a consulting company and since sold that off. But we've consulted for probably about 150 different unique entities, and out of that, hundreds of different control system environments that we looked at. And quite commonly, we would find control system logic stored in the corporate network and not stored in any protected area. I mean, that's one element right away that if that's not protected, an attack could literally be just trying to manipulate some of your sensors to force some additional compressors or pumps to turn on that you never anticipated because there was some faulty sensor logic put in place because somebody knew your logic that you have. So the point is, I'm just bringing this out as an example, you want to have a complete cybersecurity program that protects the confidentiality of the logic that's running your process. Maybe it's even, again, trade secret information that you're trying to protect. But then further getting into your schematics and even looking at your vendors and how they protect it, if you're not providing guidance on how to provide this information, well, then they're not going to be looking at finding a way to protect it any differently than possibly just open email use. And we see that quite commonly. Now with the consulting hat on, and Chris brought this up as an excellent point, you have to know what is running your control environment. You have to know the cyber assets that are there. You need to know the software that's in place. Well, if you don't have a good information protection program in place prior to doing that, what you may do is just go out there and do inventory of all your systems that you have, and the next thing you know, it gets shipped around in emails, and that critical information and attackers can now use you as really a tool of finding the pivot points that they're going to be using. So make certain that you have a process in place of information protection. I'll cover a couple more in a moment, but I just wanted to bring that out. Ultimately, the attack vectors we've seen aren't new from cyber to the vectors from hundreds of years ago from a category perspective. Generally, it's to try to take advantage of the tools and the engineers, tools and mechanics, the people behind the tool sets and the access credentials that somebody uses. If you can pivot through that person or through the technology or through the access portal, then you're going to be able to get into the environment. And that's no different than your Trojan horses from, again, the Roman Empire and thousands of years ago as we get into some of those challenges. It just has transitioned over to cyber environments as we do this. So, here's an example. A lot of warnings came out in the late 2000s around USB flash drives, and people are much more aware of bad USB and bad BIOS and some other elements that are out there. But how far does that extend into your environment, right? I mean, Could somebody just go and compromise a USB license dongle? Could somebody compromise a PLC cable that has a USB entry point? Are you using USB Bluetooth mics that are in place, right? Are you using wireless in environments? And then even what do you consider wireless? You know, the last control environment that we went into as an assessment, and I still do a couple a year besides just education, they happen to have wireless cranes that were in place. So it wasn't actually the true control environment of the product they were producing. It was the supporting system around it and the 10, 20, 30, 50-ton cranes that were in place, and they had moved from a wired cable to a wireless cable. And you know that wireless was put in place to just merely have security to manage interference or the risk of another provider having a wireless solution in the same frequency space, but not for a security consideration. So when you think about wireless, think about plant communications, think about walkie-talkies, think about wireless HART, think about Air Trial 11, think about 900 megahertz, think about all these elements that are wireless, and then start discussing, hey, did the vendor truly think about security, or were they thinking about other means as they put in this wireless capability? It doesn't have integrated security into it. So ultimately, what we try to do now as advice educationally as a consulting entity is just to think about things inversely. Right? I mean, it's a great framework that NIST put together with the cybersecurity controls that you should put in place and the 5-step process, as well as another great framework being 882 that talks about control system cybersecurity. But back in 2006, I had the opportunity personally to give some education in Japan and literally, for the first time, watch my message be lost in translation, right? So, stealing from Bill Murray and his movie, but point being, I watched, through translators, the message just get lost. And it kept me up all night, mostly because of the time change between Tokyo and Chicago. But nonetheless, I was up all night just trying to figure out how can I invert this model. And at that time, it began with 26 tenets, but now it's been shrunk down to 3. And those 3 are to think that by default, anyone is eavesdropping on your conversation, anyone can steal or misuse your assets, and that it is actually contested territory. So what we're doing with our security controls, physical, cyber, operational controls, is to try to make certain that we can mitigate and invalidate in some fraction these individual tenants, right? We don't want these things to occur in our environment. We want to be able to manage it. But what has changed is what Chris brought up, is that absolutely this is contested territory. We have to assume that we're going to be compromised. We have to make sure we have an instant response plan in place that can actually address that potential outcome. And quite commonly, I would say probably on the order of about 90%, when we look at instant response plans for cyber events, we hear from the entities as we did consulting that they had never executed that plan. What that means to me really is they haven't had visibility or good enough tools in place to have the visibility of potential systems being compromised or things happening in the environment where they would use that plan. Or possibly the plan should have been used and it just wasn't, right? So then you get into what if a virus is identified in a control environment, which of course we've had plenty of those even over the past decade. You can even go back to the Zotab worm and SQL Slammer from over a decade ago. A lot of those impacted control networks, not as a direct target, but as consuming the bandwidth on those networks at that point in time, leading to the outcome of, hey, disconnect from corporate, right? And I've seen plenty of environments where they go into isolation mode, or they remove that network jack, or they actually have a little wire tag that says, if corporate is infected, pull this cable. So that leads us into what are some of those simple steps to begin. And I gave away one of those with information protection programs. Make certain that you have a solid information protection program in place before you start inventorying your most critical of cyber assets, right? Because that now is something that an attacker really wants to gain a hold of. If they have a diagram of your network, they want it. Of course, you want it. You need to have it, but it needs to be protected. Furthermore, make certain that you truly have backups of the systems that are there and of the logic running on them. And that those backups are readily accessible. You just don't know what's going to happen. If the plan is going to be that an event is going to occur, how do we rebuild when that event occurs? And you want to have access to that at that point in time. Change management programs. I can't even tell you, I can tell you how much pain it was, but how many times we would go into a facility prior to us standing we actually changed our communication to our customers to say, please have a good change management program because we don't want to go in and inventory your systems and then next week find a whole new set of connections or a whole new system put in place that was put in place over the weekend. And it took 2 times, shame on me, it took 2 times for us to actually have that happen. We then changed our process as a consulting entity to then say, hey, do you have a good enough change management program where there's not going to be changes after we inventory your connections, your systems, your field devices, everything that's here on this network and how they talk to each other so that we don't have to go and redo it 2 weeks from now when there's an unknown change that occurs by a different business unit that you just didn't understand was happening. So make sure that's there. That's a commitment to security, right? I mean, that's that translator that can be there going to the boardroom. Again, Chris brought that up. That was fantastic. That should be able to manage that type of situation and serve as that centralized change management element. And then an instant response program. You have to have it. It's not a matter of if, it's a matter of when. I will tell you that we're even doing education now of that new normal, right? What if something were to happen? The consulting company that I was co-owner of, we focused on NERC and we were dealing with the electric sector, and of course that was the touch point initially. And what if this goes away? What happens if there is a 10-day, 30-day, some longer duration of outage that we need to get things rebuilt and operational, and in what order? You don't want that to happen. You want to be well planned. You have an excellent business continuity plan. You have an excellent secondary safety system in place, most likely. But do you have, how often is that tested? Do you have a thought process of how you're going to communicate if something becomes untrustworthy? And that goes back to the title of this presentation. That's all we're doing with security, whether it's physical or cyber. We're just trying to validate trust. We're trying to validate trust on an ongoing basis. And it's become hard because we're so removed from the supply chain, from the firmware updates, from the actual underlying elements of our control environment. They literally are children that have to be babysit, and they're fully trustworthy from the industrial protocols that are put in place and how they communicate to the logic that's there. They are designed to work really in a lot of closed-loop environments, but we've opened them up with a lot of additional connectivity. Further, when we do our investigation, you really have to think about indirect systems as well that may be impactful. So physical security, could that be the gateway? The great example, again, the pipeline that went through Turkey that was revealed just before around November, December of last year, showing the physical security element as the pivot point into the control environment. Heating, venting, and air conditioning, a great example, again, there that wasn't the target of the attack, but what if somebody were to manipulate the sprinkler systems where your control sensor is? How are you managing your building management system and backnet that goes along with it? To water towers and water supplies, a lot of our control environments have a direct relationship with the water supply being readily available, and how is that being managed, to wireless cranes and any type of telecommunications networks that are in place. So those are the supporting systems as wrappers and understanding those dependencies that you have in place. What should you look for if you're doing this inventory and investigation? Number one is physical location of your devices, your cabling, all the supporting systems that are there. Where are the tool bags? Do you have a check-in, check-out process for the laptops that are used as transient systems between your control environment and corporate? Do you have the same thing with your USB flash drives? Do you have the same thing with these tools? And how do you evaluate the trustworthiness as they go from one network of less trust to one of more trust? I mean, that sucks that, in a nutshell, right, of taking advantage of the engineer and these transient systems that were in place for that quote-unquote air-gapped environment. Understand the communication networks. Chris brought this up as well. But then knowing what's communicating on them. Not just talking about hey, we're talking to a PLC, but truly understanding, hey, this is DMP3, or this is Modbus, or this is Profinet, and truly seeing the relationship of the devices that are talking and speaking with each other. It can show up as a sore thumb right away, very easy identification with communication networks if you can visualize and see how these devices are talking to each other, and it's very invaluable. We really like, when I have my consulting hat on, shadowing the process of, hey, you know what, engineer or entity, can you do a software update? Can you show me this process? Can you do an antivirus update? Can you gain remote access to systems? Let me watch how you do this, so we can see if there's any adjustments or guidance that we should give you in the actual task that you're going through. So shadowing of the environment is very, very important to make certain to see how, again, these updates occur, how are there break-fix situations that occur, how do you have scheduled outages, how do you manage security during that outage, how do you manage your contractor pool and their systems and how they gain remote access or physical access to the site. Those are all great elements to be aware of during your inventory investigation. Knowing your supporting systems, right? Quite often now you'll see backup generators that are shipped with communication networks in them. That's been happening really for over the past decade, that your backup generators. Or maybe an emissions control system has been set up where now it can actually trip the unit or shut down operations in some regard. Vibration monitoring, the same thing. So also you're then trying to figure out what is most critical so you can then go ahead and protect that environment. And with that, understanding where you have a manual process or not is a good entry point. A manual backup, some other process you can step through if something is compromised and the cyber is no longer trustworthy. Some other protections that make sense, getting very specific, doing file system and network interaction hackers and system access controls in Windows, having an IDS in place. This is the one element where there actually truly is guidance of having threat intelligence and early indicators with honeypots and canaries. These are additional systems that if anybody interacts with them, they're malicious or misconfigured. They're not legitimate systems. They give you early indication of an attacker before they hit a valid system. That is invaluable to have that. And again, ultimately what we're trying to do is maintain trustworthiness. And as was brought up earlier, having some additional way to have an ongoing security awareness. And that's why that question about the ICScert was brought in place. To match up with these protections, how does this make sense? The thing that changed over the past 7 years is really what I would label as the Gatling gun moment, around World War I. That is what's changed. Cyber is the fifth military domain of the U.S. military and also militaries around the world. There are cyber weaponry being developed, and by being connected to the internet, you are on the digital battlefield, period. So it is your obligation to remove yourself from it and to monitor it to make certain that your environment's not being compromised. So, there is some advice by some popular ICS vendors that you really shouldn't even be connecting any of your communication networks, ICS networks, to the internet, any critical infrastructure in the internet in any way, and that it should be going across private infrastructure, and that the concept of VPNs just is not sufficient. So you have to establish a balance and understand what you need to do, but realize that's what's changed. Basically, we've suffered that Gatling gun moment in the environments. I have another survey that we're going to push out now. It's on one of the last bullets there. This survey specifically is going to be around something that's very important to really manage that Gatling gun moment, to be able to have investigative view into your critical operations from device-to-device communications, what kind of devices you have on your network, what industrial protocols they're using, how they're speaking to each other. Do you have validation that you're not talking to the internet directly, or who you're talking to on corporate areas of less trust? And that question is around, do you have spanned or mirrored managed ports in your environment? Do you have the ability to establish these network taps? Do you have the hardware or software or the support agreements from your ICS vendors that even allows you to do this in your environment? Because ultimately what we're trying to do is have a way to have sustainable protections that are in place to be able to manage this transition between different trust levels and environments, whether it's remote access procedures, whether it's managing that wireless crane that I was talking about before as a SCADA point that an operator is going to be managing. I mean, there's just a lot of elements that you can have in place to make certain that you can protect your environment without necessarily having to go and reinvent the entire wheel. You can absolutely do a lot of things. And of course, your goal is, can you isolate and rebuild trust at some point in the future if something were to happen? So again, the response here, 75% of the participants said that they do not have a way to be able to go and have those span mirrored managed ports. You need that. If you want a hot topic to focus on over the next 12 months or even sooner if you can, but I know how long this is going to take to be able to build it into your environment, focus on getting those tap points in place. You need visibility into your environment, and you can do it. What's going to happen is there's going to be a response, oh, it's going to impact our scan rates, or it's going to impact our operations. Well, you know what? direct them to me if you want. We can have an offline conversation one-on-one, and I'll tell you all the reasons why that's most likely not going to happen, as well as ways to prove it out. But that's a major element you want to have in place. Some other recommendations, and I'm going to be wrapping up here. Some big next steps. I always like when you have a presentation, what can I walk away with and things to start looking at? I know there was the question of, hey, why are you looking at frameworks? I'm going to go back to that. I do recommend, in 2012, Qatar set up the National ICS Security Standard because of some major cybersecurity events they had there. It's gone through a couple iterations. Take a look at it. Focus on just 2 simple steps, the 20 critical controls of inventory authorized and unauthorized devices and software. Review this freely available CSET program provided by the ICScert. It's a Windows application that you can use, literally, Microsoft Windows application you can use to step you through some questions and the process of establishing a risk management program around ICS environments. And that's a good start. It's not perfect. None of these things are perfect. Perfect is we have to have good procedures that go along with this. And again, even that's not going to be quote-unquote perfect. And then I give you some other labels to look at. NERC SIP, we heard about that. ISA 62443, again, really I would say a budding, emerging set of cybersecurity controls, as much as ISA and ANSI is very prominent. Still from a cybersecurity perspective, it's pretty emerging. And then the NIST 882, and there's several of these. You'll have a copy of this presentation, or again, write these down. I'm not going to go through them individually, but these are good guidance to be able to manage change management, incident response, ICS cybersecurity controls, and understanding this control nomenclature. So the other big element is, hey, wouldn't it be better just to also focus on how can I reduce my scope of work? So not just thinking about how we're going to secure the environment, but how can I actually reduce my scope of work? And one of those is start thinking about, hey, is there software I don't need? Are there communications that aren't necessary, devices that aren't critical, user access is too broad, or just systems that are just too difficult to understand or support? If you can get those out, that's even better, because now you don't have to support them in the future. I know, again, I'm maybe preaching to the choir a little bit here on some of this, depending upon how much history you have in your space, but point being, we want the more systems that you have and software and user access that you have, the more challenge it's going to be to actually have good cybersecurity controls on this open, worldwide digital battlefield. That's our struggle. We are wide open to the entire world as our threats that could be impacting our environment. So why should you be trying to defend a very wide space if you know these are systems that you truly can remove and move out? So again, thank you for your time. I recommend taking a look at some of our training and our research platform we have in place. And I think we're going to be opening it up to some questions here at the end too.
Right. You can type questions for Chris and Matt in the Ask a Question box on the screen, and we'll get to as many as we can. We've got to wrap this up in a few minutes here. Within a few days, this presentation will be available for on-demand viewing on the Control Engineering website, and we will send you an email message with a link connecting directly to it and related resources after it's ready. Now on to some of the questions. Here's an interesting one. I think it's could be for either one of you. How do you strike the balance between a secure control system and the ability to provide current plant status to external management? People are talking about all these wonderful things that you've got to be able to access what's going on in the plant from halfway around the world. How do you balance that?
Yeah, Peter, this is Chris. I think the good news is that's absolutely positive and doable. Some people have the impression that you have to choose one or the other. There are some fundamental principles in how you build a system that allows control system data to go outside of the control system environment and to the business network, and that a trained cybersecurity professional would know. I would briefly refer back to, I'm going to try to find the slide to show folks, if I can, that may help us to understand that. Yes, you should be seeing the custom cybersecurity profile slide there. This isn't exactly what I want to refer to, but let's take this slide as an example. So if I want to get, for example, data historian data out in some format to someone on the business network in this slide, then the DMZ that I show here with servers is one mechanism that would help me to do that securely. And that is the control system or the data historian on the control system would be allowed through the firewall to push its data up to the servers in the DMZ, but not allowed to talk directly to the business network. The business network would then be allowed, in fact, just one server I would say would be one good example, or one set of systems on the business network would be allowed to connect to the DMZ to pull that data into the business network. But the business network would not be allowed to go to the control system. So that's a very brief example. There are other elements that you would want to put into that design to make it secure. But you could contact either Matt or myself, and we'd be happy to help you do that.
Okay. Now, one of the things that we talked about earlier was the ICScert. What are some of the other things that Homeland Security is doing to drive cybersecurity programs? Matt, you want to take a whack at that?
Sure. This is such a major topic that there's a lot of entities that are trying to help with this. And of course, the ICSGWG, which is spun out of DHS and ICScert, I highly recommend, if you're not familiar with the Industrial Control System Joint Working Group, that's what that's called, here in late October in Savannah, Georgia. They're having their next meeting. It's a fantastic forum for you to, not only hear, it's really to hear from each other. It's not from the DHS. They facilitate it, and a series of volunteers facilitate the meeting. But then you can have those conversations with your peers. And I have that question quite often whenever I'm educating. And it's, Matt, how do you keep up to date on all this stuff? And as many of you know, the longer you've been in the industry, it's all about having a good peer network in place. Google is great, but the best search engine out there are other people. That still is true today, especially when we get into more emerging threats and some of the challenges we're dealing with here. So, the ICSGWG, that's a great point. I talked about the CSET program that you can get, again, out of the ICScert. And I would just, if you haven't, with the response that came back on the ICScert, I would say definitely start digging through that area to see some of the vulnerabilities that have come out, the categories of vulnerability. It's just a great start.
Okay. I think we've got time for maybe one more question here. Chris, I think you were the one that was talking about sandboxes. He says, where do the executables that are analyzed in the sandbox? Are they emails? If that's the case, why not just block emails that have executables attached to them?
Yeah, that's a great question. So the sandbox technology certainly can be used to grab executables that are going through in emails. And if you have that latitude, then you can simply block executables in emails. Keep in mind, though, that malicious code can be represented in Word documents, Excel documents, as well as .exes. So if you can block attachments to emails, that's great. That's not always practical. What the sandbox technology does is it really doesn't block anything. But what it does is as it sees files flying by, and let me pause to say, this would also be files that are coming in via the Internet. So if your internal users are browsing to the Internet and going to websites where inadvertently, hopefully, but still they're pulling back malicious code from the website, that's not going to go through your email path. So it's not going to get stripped, even if you're stripping all email attachments. It's going to end up at the end user unless something in between the end user and the web server blocks it. The sandbox will grab a copy of those malicious files and run them in a virtual machine to see what they do. And that's always going to be more effective than an antivirus piece of software trying to determine if that's malicious. So the good news about sandboxing is it's most effective. The bad news is typically it doesn't block. It just informs.
So sometimes it isn't so easy to spot those executables.
Correct. They may be obfuscated because they may be encrypted or encoded, which opens up a new conversation we probably don't have time for.
Right. Well, that's really about all the time we've got today, I'm afraid. So thanks again to our speakers, Toby Cahoon, Chris Shipp, and Matt Llewellyn, and for sharing their time and expertise.